This video is brought to you by thepuzzler.com.
In this video, we'll be looking at how to find the area of triangles, the Pythagorean theorem, and the triangle inequality, plus a lot of AMC8 problems that involve all three of these concepts.
Homework for today's class will be available at thepuzzler.com/AMC-8-bootcamp. Let's start with today's class. At any time during the class, you can ask any questions or answer any of the questions on the screen using the chat feature. Okay, let's see if everyone can hear me. Just a quick audio check before we get started. Just a quick yes in the chat if you can hear me. Okay, I'm seeing some yeses. Then let's get started. Okay. So today we'll be learning about triangles. Triangles are just very important, right? They're the essential building block of geometry. That's very important. Any shape, any polygon, you can break it down into triangles. You have a square, break it down into 2 triangles. You're dealing with a hexagon, break it down into 6 triangles. So they're really useful. So we'll start with them today. So this is part 1 of a 2-part series, right? Next week we'll look at more advanced tools. Today we'll be doing some easier tools. Ishan, we will not be learning about trig, but we will be learning about some special right triangles that are derived using trig, right? You can derive them using trig. So usually trig doesn't show up in AMC8 problems, but some special right triangles do that are originally derived from trigonometry. Okay, so you have a triangle right here. The area is simple. Base, so take any side as the base, multiply it by the height of the triangle. So multiply it by the height, which is h in this case, and then divide by 2, okay? So basically, it's like a rectangle, right? We multiply the base times height. But why do we divide by 2? Well, imagine that you double this same rectangle. We flipped it around, maybe along one of the upper edges. Here, I picked this edge right here. Well, to make us, that sort of makes like a square-like shape, right? More specifically, a parallelogram, which can be changed to a simple rectangle. We do a bit of transformation, right? And you notice that this is just the same triangle, b times h, except we're only taking half of it. We've only taken half of the triangle, right? Because this yellow part and this part add up to this part, right? Because of this transformation right here. So that's why we have to divide by half. Okay. Let's continue from here. Okay, I just have a quick problem. I know most of us know how to find the area of a triangle, but just to make sure that everything's clear in our heads, I have a problem for you guys. Try solving this one. Make sure that you don't accidentally multiply by the wrong height or the wrong base. Remember, area is just base times height divided by 2. Okay, seeing some answers in the chat. That's good. Ooh, different answers. I'm seeing all different answers. Okay, a few of the same answers. Let's see. Okay. Let's go back here. What do we notice? What's the base? So I could pick any side as the base, but they've only given me one exact height, right? So I have to continue with that one height that they give me. And that height just happens to be, that base happens to be this one because the height is this, right? There's no other height that they give me. And how do I know this 5.8 is a height and it's not some diagonal? This right angle symbol, that means that the two lines are perpendicular. that means that it's the height of the triangle. Okay, so I'm seeing two different answers mainly in the chat, but I'm suspecting a lot of people forgot to divide by 2. Let's see. So we have the base. So the base is not 7.5. Don't add up 1.5 plus 6. That's very important. Do not do that. The base is only 6. The height is not 6. The height is not this. The height is this, 5.8. So we multiply 6 times 5.8 and we divide by 2. This is 3 times 5.8. Okay, 3 times 5.8, you can use a calculator, but you don't need to. And since you're not allowed to on the AMC8 test, I'm going to do it without a calculator. 3 times 5, so just do it separately. Basically, in your head, you should rewrite 5.8 as 5 plus 0.8. And now you can use the distributive property. This gives us 15 plus 3 times 0.8, which is 3 times 8, 24, divided by 10, 2.4. This gives us 17.4 as our answer. So a few of the people in the chat wrote 34.8, and I think what they forgot to do was divide by 2. So that's where we get our answer of 17.4. Quite an easy and trivial problem. Rarely will you see on the AMC8 a problem that can be solved just by plugging it into the formula. Here's a problem that might appear on the AMC8, right, on the easier end. The area of a triangle is 22.5 units squared, right? It's area, so don't forget that squared symbol. When it's a multiple choice test, we don't need the squared symbol, but in general, on a school math test or anything related to that, you do. What is the length of the base? They already set a variable for us. How nice. What is the length of the base of the triangle? So the first thing in these type of equations is to usually set a variable, right? But they already did that. What's the next step in solving these equations? Okay, let's see. In the chat, I'm getting a few different answers. 9, 45. I also see 45. What else do I see? Mainly 9. Let's see. Okay, so we have base. The base is b times the height, and I know 5 is the height because of this right angle symbol. That means the two lines are perpendicular, so that's the height. Base times 5, I'll just write the 5 at the beginning. So 5b divided by 2, since it's a triangle, is equal to 22.5. So the next step after the variable was to make the actual equation, which I just did. And now we just solve. 5b is equal to multiply both sides by 2 to get 45, and that b is equal to 9. So the answer to this is that b is equal to 9 units. Okay, so that's it for area. Not going to look at anything too hard. We're actually going to move on straight to the Pythagorean Theorem. And the Pythagorean Theorem is just really cool. It's just a very cool theorem. It was founded by Pythagorean, although it's said that it's also been found by other people before that. So the Pythagorean Theorem, but we call it the Pythagorean Theorem. It's a theorem about right triangles. And what it states is that in a right triangle, the two legs, which is like the non-diagonal side or the two shorter sides, well, if you square both of those sides and add them up, you'll get the square of the third side. So a squared, a is the first leg, and b squared, add them up, and you'll get the square of the third side. So the thing is, if I were to plug in a random value for a, let's say I plug in a equals 2, b equals 3. Now if I want this to be a right triangle, we can figure out the value of c. Let's plug in 2 for a and 3 for b. yet 4 plus 9 equals c squared, or that c is equal to square root of 13, right? So that gives us a square root, and most of the times it is a square root, except when it's not. So someone in the chat wrote, this only works on right triangles. Correct. And as you advance into like further math journey, you'll see there's a general formula, there's a general example of this that you can actually use. It's called the law of cosines that you can use on any type of triangle. Don't worry about that right now. The Pythagorean theorem, and it's only for right triangles. So what we have here on the screen are some Pythagorean theorems, right? Pythagorean triples. And these are very important because these are triples that you can plug in the first two values for the legs and you can plug in the third value for the value of c, right? Someone in the chat just wrote c equals hypotenuse. They're correct. A does equal the base and b equals height, but it could also be the reverse. B could be the base and a equals the height, right? So we have these triples. These are just the first few triples. There's actually an infinite number of triples that when you plug it into the expression, you'll get a perfect square. So for example, 3, 4, 5, 3 squared plus 4 squared is 5 squared. Is that true? Let's check. 9 plus 16 equals 25. And that's correct, right? So basically, all of these work, right? And it's a good idea to memorize these because they do appear on AMC8 problems. They appear on other contest problems also. So it's usually a good idea to make sure that you memorize these triples, at least the first few. I would say if you memorize it to this point, so the first 5, this one, this one, this one, this one, and this one, you'll be fine. Okay. One more important thing about that. You can take any multiples of these triples, right? So you can multiply each number in the triple by the same number and you'll get a new triple, right? So that will also satisfy the Pythagorean theorem. And let me prove that here. So we have a squared plus b squared equals c squared. And it's true, right? A, b is from here, and then c is the third part of that coordinate point, right? Or the ordered point. Now, if you multiply each number by k, instead of a, we're squaring ka. And then instead of b, we're squaring bk. Let's write it in that order. And then we're squaring ck. Right? So this is my new triple with ka, bk, and ck. We're going to get k squared, a squared, plus k squared, b squared, equals k squared, c squared. And a lot of you probably see this. You can divide all the terms by k squared to once again get a squared plus b squared equals c squared, which we know is true. So that just tells us that, for example, 6, 8, 10 is a triple, right? If I multiply each expression by 3, then I get 9, 12, 15. That's also a triple, and so on. Okay. So I want to just see how quickly you guys can solve this. I'll still give you the normal 60 seconds just in case someone actually wants to double check using the actual Pythagorean theorem. But this is a Pythagorean triple. Try solving it without using the triple and like just plugging into the formula. And then try solving it while you do know the triples, okay? And we'll see. Just notice which one is much faster. Okay, so I'm going to solve this both ways, with and without the triples. Let's go use with the triples. 24 and 7, is that a triple that I have? Wait a second. I have that triple. Oh, it's one of the 5 that I asked you to memorize. So our answer is just 25. Now let's check it the good old-fashioned way. 24 squared plus 7 squared equals c squared. Do the computation. 24 squared, what is that going to give us? I think that's going to be 576. And you can actually compute that. I use some memorization to do that, whichever one works for you. 7 squared is 49, and this equals c squared. C squared is then equal to 576 plus 49, which is plus 50, minus 1, so let's make this 5. And this gives us 625. So then C is equal to 25. That was what I thought that way. So both ways work. Obviously, the first way was much, much faster. Another Pythagorean theorem, not a triple, a theorem. So this problem also uses the Pythagorean theorem. What is the length of the diagonal of a rectangle of length 3 and width 2? So this problem, it also applies the Pythagorean theorem, but you sort of have to notice how and why. You might need to draw a diagram, right? I just gave you a hint. That diagram might be a rectangle. By the way, if you finish this problem early, make sure that you've given this video a like, okay? That helps us really get this boost in the YouTube algorithm. So make sure that you give the video a like. Okay, seeing a lot of the same answer. That is either a really good sign or a really, really bad sign. Let's take a look. So I'll draw a diagram. I have a rectangle. Well, I'll try drawing a rectangle. Okay, that's a rectangle. Assume those are straight lines. And we have this side is 3, this side is 2, or reverse, doesn't matter. And what we have here is this shape right here, this diagonal. And what do you notice? We got a right angle right there. Our sides are 3 and 2, so 3 squared plus 2 squared. That's going to give us 9 plus 4 equals 13. And this is equal to c squared, right? So we take the square root of both sides, and we get c is equal to the square root of 13. So this one, it's that easy, square root of 13, right? If you were overthinking that one, you didn't have to. Let's try this one. We have to find the value of AC. And this is a problem that could, I don't know if this exact problem appeared on the AMC10 or the 8, but a problem like this is something that would definitely appear on the AMC8, right? Different numbers maybe, but the general concept is what we need to get down. It's a big hint that we know that we have to use the Pythagorean theorem, but from there, it's up to you to solve it. Okay, let's see how to do this one. Any answers in the chat? I'm seeing a lot of 21s. See how close 21 is. Or if that's the correct answer. We have AC, right? So I don't see a way to directly find AC. If this was a right angle, I would have this as 10 and this as 17, and I could just apply the Pythagorean theorem. I don't see a way to prove that is a right angle, and I have a feeling that it's not a right angle. Let's see, what else can we do? Well, notice that AC, that's equal to AO. AO is this part right here. AO plus OC. Okay. Well, AO is part of a lot of right triangles. Or maybe not a lot, but at least 2 right triangles, right? AOD is a right triangle. This side is 10. And what else do we have? We have this other side is also 8. So what about this side? Well, if you remember from the triples, we have that 6 squared plus 8 squared equals 10 squared, right? That's actually a multiple of the 3, 4, 5 triple. So we have 6, 8, 10. Then, like, who mentioned it? Then, like, just like Colin just mentioned in the chat, we have a triple that I did ask you to memorize. 17 as the hypotenuse, 8 here, and 15 here. So AC is equal to AO plus OC, or more specifically, it's equal to AO plus OC. Oh, AO plus OC, which is 6 plus 15. So our answer is 21 for this problem. Okay, let's move on. Let A be the area of a triangle with sides of length 25, 25, and 30. Let B be the area of a triangle with sides of length 25, 25, and 40. What is the relationship between A and B? It does show on my end that there might be some audio issues, so if you guys have any audio issues from me, just let me know. Okay. So what do we have here? We have that there's 2 triangles. What's the comparison between the areas? They gave us all 3 sides of the triangle. I'm going to give you guys either 60 seconds, or if I don't see too many answers after 60 seconds, I'll move it to 120 seconds for this problem. Okay. Okay. Do I see any answers in the chat? I'm seeing C's and D. Okay, I'm seeing both C and D. I think we can go for 16 more seconds on this problem. Let's see. Just double check your answer, right? It's an AMC8 problem. Only one of them is correct. Yeah, I see Leonardo in the chat asking someone else for the explanation. Go ahead. That is always a good thing, right? We always want to double check. I will give you a hint. It involves breaking up triangles. Okay, let's see. Let's try solving it now. I think a lot of you are starting to get it. Let's try. So we have a triangle A. Okay, so right off the bat, I noticed that both triangles are right here. They're both isosceles triangles. They don't look like right triangles, right? That doesn't look like any one of our Pythagorean triples. Even if you divide all the sides by 5, doesn't look like anything, because none of our Pythagorean triples had two sides that are the same length. So we'll have to see. Okay, so the longest side is 30. It's here. And the bigger sides are 25, 25. Similarly, we have 25, 25. Okay, so now this side is 25, 25. This is 40. Now what? It looks like an isosceles right triangle. I mean, isosceles triangle, no right triangle. Well, one thing that you should always want to do with isosceles triangles is to break it in half, right? And the thing is, this line, it's also the height. It's a height, so it makes a right angle. And it divides the leg, or the base, into 2. So that means that this is 15, this is 15. This is 20, this is 20. And now I think some of you are starting to see it. We have a right triangle. This triangle right here, for example, this triangle is right. And it's actually a Pythagorean triple, 15, 25, and 20, right? 15, 20, 25. If you divide everything by 5, you get 3, 4, 5. So yeah, you also have to recognize multiples. You don't have to memorize them, just recognize them. So this is 20. Similarly, we have the same triple on this side. 20, 25, and then 15 is going to go here. So we have 15 here. And now we can see where this problem is going. So we have our base as 30 for this triangle. Height is 20. And then divide by 2. That gives us 300. What about this here? Our base is 40, so we seem to be getting a different answer. And our height is 15 though. Divide by 2, that gives us 40 times 15 gives us 600. Divided by 2, wait a second, that also gives us 300. So that means the area of these two triangles are the same. That part didn't make sense to me the first time I solved this problem. But what we did, everything, you can retrace this, everything is fair and valid, and these triangles are the same. The answer is A equals B, or C. Okay, it's giveaway time. And our previous winners, Sunita Rao Chaudhary and Andy Cheng, feel free to email me to claim your prizes. So we are switching up the giveaway prizes this week, right? We're going to actually be doing 2 interview cake module access, and they're each valued at $169 each. These are really good just if you really like coding, programming. These are just really good. They give you a lot of coding and programming problems that you can just really try. And it's almost like problems that they give you at real big companies like Google. And once again, you can go to thepuzzler.com/AMC-8-bootcamp-giveaway to enter. I'll give you about a minute to enter. It's okay if you can't enter right now. You can always enter after the class or later. So I was looking at the stats for this video over here, right, for our AMC8 series. I noticed that a lot of you aren't subscribed to our channel. So make sure that if you haven't subscribed to our channel yet, make sure you do that. In the chat, I'm seeing Cake Modules. That's the name of their company, Interview Cake. The people that were kind enough to provide us these, their name is Interview Cake because they believe they can make interviews a cake. A piece of cake. Okay, that's enough time. You need more time, you can always enter afterwards. And now we're going to be doing something called a triangle inequality. So this is actually sort of advanced. It appears in the AMC8, but the problems can get really, really hard. The triangle inequality, it's very simple. It states that the sum of the lengths of any two sides of a triangle is just greater than the length of the remaining side. Right? So we have x plus y is greater than z. Right? X plus y is greater than z. What if x plus y isn't greater than z? What if we start pressing it downwards? Let's start pressing it downwards. So what I'm doing is I'm pressing this x side over here and y side over here. I'm pressing it downwards. As I'm pressing it downwards, notice what's happening. As I'm pressing it downwards all the way, eventually I'm just going to end up with a straight line, right? Where the side, the x side is maybe right here. So even though you see a tiny space right here, that space isn't actually there. That's just because I want to show you that they're two separate sides. And y right here, right? So now we have x plus y is equal to z, right? Because x plus y, it's the total length, and it's equal to z. And believe it or not, this is actually a triangle. It's called a degenerate triangle. Most problems, when we're dealing with them, they either say it or it's just assumed that we're not dealing with degenerate triangles. That's just something that we assume. But it is a triangle. It's called a degenerate triangle. So anything above that, though, even if there's a tiny space, so basically when the area is non-zero or when the area is positive, anything above that, notice that these two sides, they'll be longer than z. And it just logically makes sense. So what we have is that x plus y is always greater than z. And this is always true. Z plus y is greater than x. There's no contradiction to this except for these degenerate triangles, right? So what we can write is x plus y for any two sides of the triangle are greater than or equal to z. And for normal non-degenerate, so normal triangles are called non-degenerate, we have that x plus y is greater than z. So for example, this problem right here, they specify that it's a non-degenerate triangle. So if two side lengths of a non-degenerate triangle are 9 and 15, what are the possible lengths of the third side? So try using the triangle inequality here. What's the minimum? What's the maximum? Can it be everything in between the minimum and maximum? Helen asked a good question. Why can't they call them degenerate triangle lines? Because it's not a line. It's actually three lines, but two of the lines are right on top of the third line. So it's actually a triangle, but the lines are just put onto each other. So it looks like a line, but it's not actually a line. So make sure that once you get your answer, first of all, we're seeing different answers in the chat. Yeah, make sure you're listing them in a valid format. A valid format would be using interval notation, if you know what that is. Best way would be to list it how Leonardo listed it, using inequalities, right? I think, in my opinion, best way, if you don't know what interval notation is, just use inequalities. Using a dash doesn't work because that doesn't tell us if the endpoints are included. For example, not trying to just pick on you, Mystical, just in general. For example, 7-23, we don't know if the 7 is included in that or not, right? And we have to specify that. Okay, so this is a non-degenerate triangle, which is why it matters if it's included or not. So what do we have? Okay, let me go back there. We have two triangles, or one triangle, and the third side, let's call it, I don't know, I don't feel like using x, let's use c, 9 plus c. So now 9 plus c, it needs to be greater than 15, right? So the two shorter sides always need to be greater than the third longest side. So if 15 is the longest, these need to be greater than 15. So that means that c is greater than 6, right? It's important you write that c is greater than 6, because if you write that it's 7 or above, that won't work, because what if it's 6.01 or 6.000001? Doesn't include that. That's not included in your domain. So that's why it's important that you use inequalities or interval notation. Okay, can 9 be the longest side? I mean, it still applies. The triangle inequality still applies, but it just doesn't make sense. Of course, it's always going to be greater than 9 because 15 itself is greater than 9. So it doesn't make sense when the side isn't the longest side. But what if c is the longest side? Then we have that 9 plus 15 must be greater than c, or that 24 must be greater than c, or that c must be less than 24. Okay, c must be less than 24. What does that mean? That means that we have a bound on c. C must be from 6, so c is greater than 6. Not greater than or equal to, because it's non-degenerate. C is greater than 6 and less than 24. If you know interval notation, you can write it as parentheses 6 comma 24, right? So starting end, and the parentheses means that it's not included, right? Square brackets would be if it is included. Ooh, this is probably a very hard problem, right? Probably one of the hardest that we're going to cover today. And for this problem, we might actually go 2 to 3 minutes long for the timers, depending on how many people give me an answer. I was cleaning up my attic recently and found a set of at least 14 sticks with a curious Italian gentleman sold me some years ago. Trying hard to figure out why I bought it from him, I realized that the set has the incredible property that there are no 33 sticks that can form a triangle. No 3 sticks that can form a triangle. If the set has 2 sticks of length 1, this should be 1. Let me just clear that up. Of length 1. Which are the smallest? What is the least possible length of the 14th stick? Okay, in the chat, I noticed 0 answers. I noticed 1 answer. I think we need more time, guys. Let's go one more rotation. I think someone got it. Han got it. Leonardo got it. That's really good. Yeah, as an extra challenge, try providing me an explanation if you know how to do it. Anyone else in the chat? Only Ahan and... Okay, we have an answer from Malru and Om. That's good. Okay, so this problem is really cool. Let's see how to solve it. If you still need more time, I'm sorry about that, but I think most of us just don't get how to do it. What do we have here? Just start from the bottom. You don't even need to think about anything else. We have two sticks of length 1 and 1. Well, the third stick, and this, I don't think they specified this, but all the triangles are non-degenerate. So the third stick, well, if we don't want to find a triangle, right? We're trying to minimize values. I don't want this third stick to be a million. A million is going to be too large, right? Because I'm trying to minimize it. So maybe this third side right here, this is going to be 2, right? Because 1 plus 1 is equal to 2, right? So now this third side is equal to the sum of the first two sides. Go on. We have 1, 2. They form a triangle with anything less than 3. Well, if it's 3, they won't form that triangle. It'll be a degenerate triangle. Make sure you're understanding this. This is a really good time to ask me how to solve it. We're basically just starting from the bottom and building ourselves up. So we have 1, 1, 2, 3. And basically what you're noticing is that it's just the sum of the last two, which happen to be the largest two sides, right? Because if it's their sum, it doesn't satisfy the triangle inequality for non-degenerate triangles. So it's not a triangle, which is what we're looking for. We don't want any triangle. So we have 1, 1, 2, 3, 5. Keep on going now. Just chug and plug. 5 plus 8, 13. Then 21, 34, 55, 89. And I think Malvu already wrote it for me in the chat. 144, 233, and 377. Right? And all I did was I added up the last two terms. I hope this makes sense, but if you have any questions, just try your best to ask me, and I'll try my best to answer it. So one cool thing that a lot of people notice in the chat is that this is a Fibonacci sequence. The Fibonacci sequence is a recursive sequence where the first two numbers are 1 and 1, and all the consecutive numbers, they're just the sum of the last two numbers. So this number right here is 1 plus 1 equals 2. Add up the last two numbers to get 3. Add up the last two numbers to get 5. Add up the last two numbers to get 8. Similarly, 13, 21, all the way. So this never ends. It's very cool, right? There's a lot of things that are really cool about the Fibonacci sequence. Okay, so Snea, what part of it do you not understand, right? Like, that's sort of vague. What part do you not understand? And same thing with you, Prudence. What specific part do you not understand about this problem? Because it's a good question. It's a good thing to ask. But what part do you not understand? Let's see. Maybe 30 more seconds to ask me questions. Okay. So I think what I need to do is, I think I'll give you guys 20 seconds to just ask me any questions that you have. Any questions? Okay, just not enough time. Snail, let me try my best to just quickly re-explain it. We have the two shortest sticks. We just found the first length that doesn't let us make a triangle with them, which is using the triangle inequality 2, right? Because 1 plus 1 equals 2, right? And the third side of a triangle can never equal the sum of the other two sides because of triangle inequality. Keep on going, rinse and repeat. 2 and 3 we get 5, 5 and 3 we get 8, 8 and 5 we get 13, all the way, right? And since we have 14 sticks, we're looking for our 14th stick, which is going to be 377, which is a very long stick though. Okay, what is this? So this one's a bit easier. What is the smallest whole number larger than the perimeter of any triangle with a side of length 5 and a side of length 19? Take 60 seconds to solve this problem. Although I suspect some of us might solve it more, some of us less. Okay, let's see how to solve this problem using the triangle inequality. So what do we have here? I'm seeing a lot of different answers in the chat. I'm seeing some 40, I'm seeing 30, a 48. Okay, Ishan even provided an explanation. That's amazing. So what's the maximum, right? What's the maximum length of the third side? Let's use the triangle inequality. 5 plus 19, that gives us 24. So the maximum is anything below 24. If it's equal to 24, it's going to be a degenerate triangle, which never is allowed except if they specify that, which I've actually never seen in a problem where they specify that. So we have that 5 plus 19 equals 24. So anything below 24, 23.99999, that works. Anything with 24 above does not work. So what's our largest triangle that does not work? Or the smallest triangle that doesn't work? That would be 5, 19, and 24. So if you add up all three of these values, you'll get your answer of 48, right? So anything above 48 can be made, right? Because a specific problem, you can actually get that. Okay, so our next topic is 30, 60, 90 triangles. So 30, 60, 90 triangles, they're just really special triangles, right? They're one of the very special triangles that we have in the math world. Let's see. So we have that 30, 60, 90 triangles, they're right triangles, right? Because we have that 90-degree triangle, they're right triangles. Oh, who do we have in the chat? Adu Bata. Shout out to Adu Bata. Okay. So we have a 30, 60, 90 degree triangle. We have this length as 1/2 h. Let me make my pen size bigger. We have this length as 1/2 h. This length as square root of 3/2, and this length as h. And you probably don't get what I'm referring to. What I'm talking about is that using trigonometry, right? Trigonometry is outside of the scope of this class, but using trigonometry, what you realize is that this bottom leg is going to be, say, 1/2. This longer leg is going to be square root of 3/2, and the longest leg is just going to be 1, which is the hypotenuse. By the longest leg, I mean the hypotenuse. Okay, so what do we have here? Square root of 3/2, 1/2 h, and h. What's important about this? Using trigonometry, we just figured out the proportion for a triangle with 30, 60, 90 degree angles. Okay, let's plug in some value of h. Let's say h is 1. Then we get that this side is 1/2, this side is square root of 3/2, and this side is 1. And what this means is that we can plug in any value for h, and we'll get a valid value for this triangle. So we can plug in 2 for h, we can plug in 3 for h. Whatever value we plug in, we can plug in square root of 89 for h. As long as these angles, it's a 30, 60, 90 degree angle, once we know one side, we already know the other two sides. Usually in the Pythagorean theorem, you need two sides, right? But here we don't need two sides, we only need one side if it's a special triangle. And you would think that these don't appear, but these actually do appear during the actual AMC8 test. This and the next type, which is a bit easier. 45 degree, 90 degree triangles. By the way, one more thing. If you want to check this, go ahead. Square 1/2 h and then square root of 3/2 h. Add them up and you'll get h squared, right? Which is what you're supposed to get. Our second triangle is a 45 degree, 90 triangle. So this is an isosceles triangle, which means that this side and this side are equal. Now you can apply this directly into the Pythagorean theorem. K squared plus k squared equals 2k squared. And this is equal to c squared. Or more specifically, c is equal to k root 2. Which is what they have right here, right? So this triangle is always in this format. Once again, you can plug in any positive values for k. Basically, you don't need to understand the explanation, right? You should understand the explanation if you don't want to memorize this, but you don't need to. What you need to understand is that in a 45 degree triangle, it always happens like this, right? There's a k, and k root 2 side. In a 30, 60, 90 degree triangle, there's a 1/2 h, square root of 3h/2, and h. Okay, let's try some problems, right? If you understand this concept, these problems are going to be super easy for you. But we're still going to do a few problems just to get the concept down. So in the right triangle below, measure of angle A is equal to 30 degrees and BC equals 6 square root 2. So they don't give us two legs this time, only one leg and an angle. But that's enough, that's all we need. How long is AC? Okay, what do we have in this problem? So we have an angle and a side. What you do have to remember is a 30, 60, 90 right triangle. And this is 30, this is 90. We learned in the last class that a triangle has 180 degrees in total. So this right here, this is equal to 60 degrees, right? So what we have is this side is 6 square root 2. Multiply this same side by square root of 3. So 6 square root 2 times square root of 3. And this will give us 6 square root 6. So this side right here is 6 square root 6. What about this side right here? Let's figure it out. We don't even need to use the Pythagorean theorem. It's just double this side, 12 square root 2. So that's the length of this side. Without using any messy work, anything like that, we just know that this side right here is 6 square root 6. Okay, let's move on. Similarly, another 30, 60, 90 triangle. This time they give us different sides. So in the right triangle shown, angle A is 30 degrees and AB equals 12 square root 3. How long is AC? Okay, so some of you might have found BC first for this problem. That's okay. I mean, that's probably how I would do it, but let's see. So we have that BC over here. BC is equal to half, right? That's very important. BC is equal to half of AB. So BC is equal to 6 square root 3, right? Because that's how it works. The angle opposite the 30-degree angle is half the angle opposite the 30-degree, opposite the right angle. And this right here is 6 root 3 times 3, times root 3, which is 6 times 3 equals 18. You could have also went straight from AB to AC, which is 12 square root 3. And then we're dividing by square root of 3. But it's not just that simple, right? We divide by square root of 3, we get 12, and we're also multiplying by 3 over 2. So that's why I just like going the BC way, right? It's a bit easier. Okay, we have a 45, 45, 90 triangle. This is much easier, right? This is much easier. You just have to remember that. In the right triangle shown, DF equals EF equals 3. How long is DE in this example? Remember, in a right triangle, it's 3. So it's if the legs are h, then the hypotenuse is h root 2 in a 45, 45, 90-degree triangle. Okay, let's see how to do this problem. It's very simple, no math involved. We have this side multiplied by square root of 2, right? That's it. We have this side, just multiply square root of 2, 3 square root 2, and we're done. The basic part of 30, 60, 90-degree triangles and the 45, 45, 90-degree triangles is memorization. Just memorize how it works, right? You can review this video afterwards, and I would highly suggest reviewing today's video after the class, and you'll get how it works. Okay, I think this is our last problem for the day, and this is actually not going to be solved using what we did today. It's actually a prelude to next week's class, right? So it's just about what we'll learn next week. This is not the hardest thing that we'll learn next week, just one of the things that we'll learn next week, how to solve a problem like this. And this is, I believe, from an AMC8 test, and it's number 16. In the figure below, choose point D on BC so that triangle ACD and ABD have equal perimeters. What is the area of triangle ABD? So try this problem. You might not be able to solve it, and you shouldn't be able to solve it. So we'll see. Just because we're running out of time, I'll stop the timer after 30 seconds, and we'll see how to solve this problem. That's great to hear, Smriti. Okay, let's stop the timer. Let's get going. So for this problem, what we do is you draw something here, and we get point D, right? We have D right here. Now we're told that the perimeter of triangle ADB and ACD is the same, right? So let's say this is X. Well, if this is X, then what is this right here? Let's say it's Y. But then what is this right here? We have that X plus Y plus 4 is equal to X plus 3 plus what? Let's say Z, right? So what is Z in terms of Y? This cancels out, this cancels out, this gives us 1, right? So we get that Y plus 1 equals Z. So I can replace this with Y plus 1. But now I know that Y plus 1 plus Y, which is 2Y plus 1, which is total of CB, that's equal to 5. I'm going through this problem quite quickly because we'll actually be doing this kind of stuff next week. So it's okay if you don't understand this. 2Y gives us 4, and that Y gives us 2, right? Y gives us 2. So that means that this right here is equal to, let me actually erase this. We have that this, let me draw it better. This right here, this is 3 and this is 2, right? Once we plug back in 2 for Y. And now maybe this is X. What is the height of this triangle to that side? We'll learn about how to solve this next week, but what is that height? Notice that the area of this triangle is, since this is a right angle, this is 3 times 4 divided by 2, which is 12 divided by 2, or 6, right? Here, the base is 5. If you flip this triangle around, the base is 5, right, from that side. So 5 times the height divided by 2 gives us 6. More specifically, height is equal to 12 over 5. So this is equal to 12 over 5. Well, notice what? For both triangles ACD, right, this point is D, ACD, and for ADB, the height is the same. So the height part of the area doesn't matter. But this right here, this is what matters. We have 2 and 3, right? So this base, I didn't draw it to shape, but what we have is this base. Okay, this point isn't D. This point is D. So this base, this is 2 over the whole thing, which is 5. So 2/5. The height is the same. And we'll learn about this next week, but when the height is the same and only the bases are different, then the ratio of the area of the triangles, that's just the ratio of their bases. So if the base is the same, we have 2 over 5 of the total area of the triangle, which I believe is 3 times 4 divided by 2, which is 6. This gives us 12 over 5 for this. And our answer is D. So this one, a bit tricky. It's okay if you didn't get it. Good job if you did, but this isn't all what we're going to learn next week. I hope everyone learned something today, but I will give you another minute to ask me any questions, right? And just to make sure that you've given this video a like. So any questions about any of the topics, any of the technical stuff, go ahead and ask me right now. And if you haven't already, make sure you give the video a like. Okay, not seeing anything. Okay. Thank you everyone then. See you guys all next week. Thank you for watching this video. If you liked this video or learned anything from it, let me know by subscribing or commenting below. For more awesome content, check out thepuzzler.com. You'll find amazing articles and free courses there. Thank you.